To making hydroponic fertilizer medium for growing plants in hydroponics. And there's only three components to this. There's the NPK fertilizer, nitrogen, phosphate, potassium fertilizer, and choose one with micronutrients. So this is an English version. In the States you get master blend. It doesn't matter too much as long as it's an NPK fertilizer with the trace nutrients. So for example, this one's got the trace nutrients of boron, copper, iron, magnesium, molybdenum and zinc. Now, when plants are growing in soil, they get quite a lot of calcium from the soil. But when you grow in hydroponics, you need extra calcium, and that's where this component comes in, calcium nitrate. Provides extra nitrate, but it also provides calcium, which is absolutely vital for plant growth. Now this is the calcium nitrate that I've got a link for at the bottom of the video, and it's taken from the international standard Yarra Livre calcinate calcium nitrate. So I buy this in sacks, but you can buy 1 kilogram at a time from me using the link below. So that's the second component. The third component is magnesium sulfate, simple Epsom salts. Now the ratio that we use is 1 of the NPK fertilizer, 1 unit, doesn't matter what the unit is, 1 unit of the calcium nitrate and half a unit of the mag sulf. So if you're using a cupful, it'd be 1 cupful of that, 1 cupful of that and half a cupful of that. Now what I do is I make up a stock medium that we will dilute 250 times. In other words, if I make up 1 litre of this stock medium, that will make 250 litres of the final nutrient solution. And I'm going to show you how we do that. So what I have here are my components, and I've got a glass, and I put A on it because I'm going to make up solution A. And into this glass, just for the purposes of this demonstration, 100 mils of water. Obviously, if you want more, you could make up a litre, 10 litres, 100 litres. You just multiply up your the materials you're putting in it. So that's 100 mils of water in there. Now, to 100 mils of water, I'm going to add 15 mils of the NPK fertilizer. This is just an ordinary baking spoon. In fact, when you buy these fertilizers, you often get these handy measuring things with it. Now when you look at these recipes on the internet, they tend to be in grams, but of course most of us don't have accurate scales that are going to measure 15 grams. But I've found out that this works perfectly well. I'm going to use 15 mils of the fertilizer. So I'm taking my NPK fertilizer with trace nutrients, and I'm giving myself 1 even spoon of it like that. So that is 15 mils in there, and that 15 mils is going to go into solution A. Stir that up a bit. Remember, this is the stock solution. This will be diluted 1 volume of this to 250 volumes of water. So just stir that up a bit. And remember the ratios, it's 1 NPK, 1 calcium nitrate, 0.5 of the Epsom salts, the magnesium sulfate. So half of 15, of course. If you put warm water in this, it helps it to dissolve a bit. You can actually buy ready-made up solutions, stock solutions, but I think it's better and more economical to make up your own. And with more expertise, you can also adjust the formula a little bit for particular types of plants, whether you're growing tomatoes or cucumbers. Just give it slightly different formulas. But this is a standard one that works pretty well for most plants to begin with. So that was, remember, that was 15 mils. So the Epsom salt is going to be half of that, 7.5 mils. The NPK fertilizer and the Epsom salt is readily available. So just an even 7.5 mil spoonful here. And that's also going to go into solution A. Now the reason that we're mixing this up into two solutions is that the calcium can precipitate at higher concentrations with the MagSulf and the NPK fertilizer. So that's my A solution made up. And what I tend to do is make up larger volumes and put it in a bottle, so I'd have an A bottle and a B bottle. Of course you could do litre bottles, you could do 10 litre bottles, whatever scale of production that you're using in your hydroponics. So that's actually I can feel that's fairly well dissolved now because we used warm water, tepid water anyway. So that's my A solution. Next, I want my B solution. So my B solution, here we are, got 100 mils in there already. And the B solution is going to be 15 mils of the calcinate, the calcium nitrate. And there I've got a 15 mil spoonful that goes into there. Mix that up. The calcinate actually dissolves fairly readily. It's designed to be water soluble. This is the one that's harder to obtain actually. That's why I bought the sacks in to sell it on in 1 kilogram bags from the link at the bottom of this video. So that's nearly dissolved already actually. That's good. So remember, this is a 1 to 250 stock solution. So for my stock solutions A and B, to make up a 1 to 250, so that's 1 of this to 250 times the same volume, 250 times the volume of water. So it's 15 mils of the NPK fertilizer. No, sorry, that's 15 mils of the calcium nitrate in 100 mils. That's my B solution. And 15 mils of the NPK fertilizer with 7.5 mils of the Epsom salts, the magnesium sulfate in 100 mils. So that's what I've got mixed up already. So there I have my stock solutions. And these all last for years. I mean, they're stable chemicals, so you can, you might just make up a litre of this, or 10 litres of this, or 100 litres of this, or whatever you need once a year. You don't need to do this very often. And it's pretty obvious which is which from the colour. Now, the next bit I want to do is I want to dilute this 250 times. Now, obviously you'd normally use larger volumes, but what I'm going to do is I've got a litre of water here. You can use tap water. If you're using tap water, best to let it stand for a little while to let some of the chlorine evaporate off. Or you can use rainwater. I like to use rainwater. I also find the pH is a little bit lower on the rainwater as well, which is often quite useful. Now what I'm doing now is I've got these stirred up. Now if I was to mix my A and B solutions now in concentrated form, we'd get some precipitation, so we don't want that. But when we're diluted in this whole litre of water, it's not a problem. Now it's 1 to 250. So 1 mil would give me, I would dilute in 250 mils, 2 mils I would dilute in 500 mils, 3 mils I dilute in 750 mils. So to put this into a litre, I'm going to add 4 mils. And just for the purposes of this demonstration, I'm going to do it with a syringe. So hopefully you can see there, we've got 4 mils. Going into 1 litre. There we go, 4 mils in 1 litre of solution A with the NPK fertilizer and the Epsom salts. And now also 4 mils of B, calcium nitrate, and you can see I've got 4 mils there. And that gives us 1 to 250. And I'm going to squirt that in there as well. give that a stir up, and that is it. That is my hydroponic solution here, and I have found this gives good plant growth to a large variety of different plants. That's it, very simple, once you've made up your stock solutions. So in this case, to make up my final solution, this is my final solution here, I've added 4 mils plus 4 mils, so 4 mils of A, 4 mils of B in 1 litre of water to make up my final solution for the purposes of this demonstration. Of course, normally you'd be using larger amounts, so it could be 40 mils and 40 mils in 10 litres, or 400 mils and 400 mils in 100 litres, depending on the amount of hydroponic fertilizer that you would like to use. So this could just be a small scale system or larger scale system, whatever you're using. Now, if you just follow those instructions, I can tell you that that medium is good for plant growth. That's fine. But what I'm going to do is just give you some proof of that. And the reason I've given you these instructions is so you don't have to buy these meters. But this is my TDS EC meter. TDS is total dissolved salts. EC is electrical conductivity, measured in microsiemens, Siemens being the unit of electrical conductivity. So let's just put it in and see what we've got. I'll turn it on first. There we are. Now, can you see there I've got 1898 in this solution. That's 1898 microsiemens per centimetre. The units don't matter too much, but we can see we've got, following those instructions, we've got basically 1900. You don't need to do this. You can if you want to, of course, but you don't need to if you follow the instructions, just to make it simple. Now let me tell you why this is important, why we need to use the concentrations as I've described them. And that's on this chart here. Because young growing plants like 600 to 800 parts per million, and that is equal to 1200 to 1600 millisiemens, microsiemens, sorry. So you can see we were on about 1800, 1900. And yeah, that's for young growing plants. Now to germinate, you want something a bit more dilute than that. But for flowering plants, for more mature plants, what we want is 800 to 1200 parts per million, and that's 1600 to 2400 microsiemens, which is equal to 1.6 to 2.4 millisiemens. So you can see that we're nicely in that range with the dilutions that I've used. Now if you're germinating seeds, you'd want something a little more dilute. For more very mature plants, you'd want something maybe a little stronger, getting on for 2000, 2400. So the units are a bit confusing. This is parts per million. That's equal to that many microsiemens, and that's equal to that many millisiemens. But it shows that it gives us the concentrations that are good for growing plants. And it's also good to check the pH. Now ideally we want the pH to be 5.5 to 6.5. Commercial growers will use 5.8 to 6 as their pH. But of course we can put the pH up and down a bit. Now this is actually tap water. And can we see there that the pH is 6.3, something like that. So what we actually want for healthy growing plants is 5.5 to 6.5. So here we've got 6.26, so that would be acceptable. Commercial growers will use 5.8 to 6. They'll try and get a more specific pH. So perhaps that could do with being slightly more acidic. So we could add a dilute acid to bring that down a bit to optimize the pH. And the pH is important because it is the pH that determines the efficiency with which the roots are able to take in nutrients. And if you're still interested, we can turn on this meter again. This is the EC meter. And we notice, that's interesting, yeah, we notice we're on about 2,000 microsiemens there, which is 2 millisiemens. So this solution would be quite good for reasonably mature plants. And actually with this machine you can change mode, and we can get that in parts per million as well, rather than take my word for it. So you can see there that that is equivalent to just over 1,000 parts per million. Again, which would be suitable for more mature plants. Okay.